Attention! There is a crime happened inside an air-conditioned room at 8 p.m. Miss Taylor is so generous to help by identifying which of 4 weapons found is from the suspect. She suggests to inspect the temperature of each weapon. So, the recorded temperature is as follows. Miss Taylor said the weapon is brought from outside, so it's ideal to assume the initial temperature of the weapon is 27 degrees Celsius. She then knew by her brain that the weapon should be at 22 degrees Celsius after being left for 10 minutes. And then, she checks the ambient temperature inside the cold room there and found that it is 15 degrees Celsius. Hence, she suggests to start with Newton's law of cooling first by following all these steps. The first step is by defining the formula. Notice that she denotes the temperature variable as W and the time variable as T, and from that formula, we can separate the variable to obtain the variable W in terms of T, but we still don't know the value of A and K. The process is shown here. We assume A is equal to E to the power of C so that it will be easier for us later. The first equation is obtained. Then, from the information obtained earlier, we know that when T is equal to 0, W is equal to 27 as our initial value. Then, let's substitute them into the first equation to obtain the value of A, which is 12. After that, we got the second equation. We just left with the unknown K. So, we use our second initial value that Miss Taylor provided for us by substituting them into the second equation. We now obtain the K as follows. Then, we can obtain the full equation completely to be used as our initial value problem in Taylor series. Let the IVP written as here. Then we let W is equal to WT to be the solution to the IVP. Now, we come to the best part in this investigation. We must follow all 6 steps provided by Miss Taylor here to reveal the murderer. Firstly, we must provide Taylor series formula. Taylor series consists of the higher order values of W and step size. As the order increases, the step size also increases by power and factorial divider also increase. We must find all the first order, second order, and third order differential equation of W to fit into the formula. The first order has already obtained from the Newton's law of cooling from before. Then, for step 2 until step 5, we assume step size h to be 10, so we just need 4 iterations with n start with 0. Then we find all the first, second, third and fourth order of DE. Each higher order needs the value of lower order to get the result. So, you must find the values step by step. After getting all the value, we substitute them into the 6th equation there. We obtain W1 is equal to 22.00. Then, we do the same for N is equal to 2 and N is equal to 3. Lastly, we obtain W4 is equal to 16.38. So, which weapon do you think is the answer? Let's see. The exact value is calculated here by inserting the value of T is equal to 40 into the equation. Since we have modulus or absolute value, we obtain 2 results, which is 16.38 and 13.61. Note that the ambient temperature is 15 degrees Celsius, which we know it is quite impossible for the weapon to be lower than the ambient temperature. Hence, the only possible answer is 16.38. So, we know that the answer is weapon C. Then Miss Taylor took a long investigation to trace the fingerprint, and finally, she knew that the person who murders the victim is David, her own husband. So sad to hear that. Why would you do that? Then, let's see the comparison between Taylor series and the exact value which is tabulated here. Notice that the percentage error is very small. So, we can say that Miss Taylor's way of solving the crime is quite impeccable since her method can really solve real-life problems.
Now, for a better understanding, let us solve some past year questions and examples related to Taylor series method. First, look at the past year question example 1. As a first step, we will indicate the important keywords that can be found in this question. Here, we have to use Taylor series expansion to prove the following approximation d2y over dx2 and dy over dx, where h is the step size. By Taylor series expansion, we have these two equations, 1 and 2. Add both these equations, we will get 2yi plus h squared d2y over dx2 plus truncation error. Rearrange the above equation, we will obtain d2y over dx2. And then subtract equation 2 from 1 and neglect term of order h cubed, we will get dy over dx. Hence, we have proved by using Taylor series expansion of the following approximation. Now, let us take a look at example 2 from past year question January 2018. Same as previous example, we will begin by highlighting the important information that we can find. Here, we are given ordinary differential equation on interval 1 to 1.6. We have to perform 3 corrector iterations per step with step length 0.2 using PC method. The starting value have to be computed using Taylor series second order method with same step length h. First, compute starting value using Taylor series second order formula. The first and second derivative of y can be found by differentiating the ODE. The first derivative equals to x squared minus y cubed, whereas the second derivative equals to 2x plus 3y squared y prime x. Then, substitute step size and initial value x and y into the Taylor series formula, and hence we obtain y equals to 0.24 when x equals to 1.2. Next, let us compute y2 using predictor corrector method that has been introduced in the beginning. The predicted value y2 naught equals to 0.576147. Once the value is predicted, we will perform 3 corrector iterations per step. Therefore, we obtain y equals to 0.598348 when x equals to 1.4. The same steps applied for iteration 3 and the results are indicated on the table. Note that the second row represents the values that we get by using Taylor series second order method, whereas third and fourth rows are by using predictor and corrector method. Hence, we obtain y3 equals to 1.227823 when x equals to 1.6. Let's look at example 3. Consider the initial value problem dy over dt equals to ty plus y squared minus 2, where y equals to 1 when x equals to 0. Using Taylor series of order 3 with h equals to 0.5, we have to estimate value of y when x equals to 1. Note that the third order of Taylor series is as follows. We have to differentiate the ODE to get the first, second, and third derivative of y before we substitute into the equation. Then, substitute h equals to 0.5, t naught equals to 0, and y naught equals to 1 into third order Taylor series formula. Therefore, from the first iteration, we obtain y equals to 0.3 when x equals to 0.5, whereas from the second iteration, we get y equals to negative 0.726195 when x equals to 1.0. As conclusion, we have tabulated the results in form of table and have successfully obtained y equals to negative 0.726195 when x equals to 1 by using Taylor series method of order 3. Well, that brings us to the end of our video. Thank you for watching.